So we're on the back of worksheet 4. 4B are some application examples that we can do together. Some on the solver, some are not on the solver. So this first one, simple interest, is found by taking principal times rate times time. But using this formula, all you're doing is you're calculating your interest that you're collecting. So go ahead and use that formula. And in the home screen of your calculator, type 4,000 times 0.062 times 8 years. Now, if you ended up using the TVM solver, a lot of things are going to be 0 in that question. It's quite boring. Typing that in your home screen, let's see, did you get like $1,984? But remember, guys, this is only calculating the interest that you accrued. Remember, you started by investing $4,000. So your total would be the 4,000 plus the 1984, so $5,984. We're going to compare the answers to numbers 1, 2, and 3, and we're going to kind of make a mental note, if not physical, about the difference in the compoundings. So number 2, it says find the total value of your investment. So same information, 4,000, 6.2%, but this time you're going to compound monthly for 8 years. So instead of just collecting simple interest one time a year, compounding monthly. So if you want to go old school with me, an Algebra 2 formula that you guys used a lot, and I know there's a variation of this on your pink card, it's P times 1 plus R over N to the NT power. Remember, if you have an older calculator, you're going to need to put N times T in parentheses. So using our data, we got $4,000 for your principal. And then 1 plus 0.062, but it's compounded monthly, so you'd have to divide that by 12. And then up in the exponent, that 12 shows up again, and you're going to multiply it by the 8 years. So calculating that in our home screen. Can you guys confirm for me that we get a $6,560.18? All right. So comparatively speaking, collecting interest monthly as opposed to just once a year is obviously giving us more money because this is like a linear growth and this is an exponential growth, so it makes sense that it's growing faster, much quicker. Let's compare this to compounding continuously. So remember, when you are compounding continuously, the formula they want you to use is that PERT formula. I think on your pink card it uses N's instead of P, but either way, it vaguely resembles this. P times E to the RT power. So your initial principal is 4,000 again. And then your base this time is the number E. It's okay. Raised up to the, thank you. Oh my gosh. Rough day, PreCalc. All right, I got them all. E to the RT power, so 0.062 times 8 years. So again, make sure if you're on an older calculator that you're using parentheses around that exponent, because it is a multiplication question. The newer calculators will automatically group them up in the exponent. Now, it shouldn't be significantly more money, but it should be more money than the last question. I got 6,568.56. Confirm? Oh, good. All right, so we noticed compounding continuously, even more money than monthly, and which that was a lot more money than just simple interest. I used to never think that simple interest was a thing in real life when I was growing up, because my teachers always told me, like, you'll never see simple interest. Turns out that wasn't true, because when I bought my first car, it was based on simple interest. So that was good for me, because if you're a consumer who's taking out a loan, simple interest is going to grow slower than anything that compounds. So as a consumer, I was like, yay. But if it was a bank account, I'd be like, boo. All right, number 4. This one, we are going to use the solver. Now, technically, I don't think we have to use the solver on this one because we're not making monthly contributions to this bank account. But I'm just going to show you what it looks like when you use the solver, even though you don't have to. So 5 years from now, you want to have $10,000 in your bank account to take a trip around the world. Hate to break it to this kid, but they're not going very far on $10,000. But that's okay. A girl can dream. All right, so $10,000 is what you want. And it's going to happen 5 years from now, so keep that in mind. Our interest rate is 5.5%, and then it does say that you're collecting your interest monthly. So for our TVM solver, the N, remember, is number of compoundings, throughout the entire course of the loan or the investment. So for us, that would be monthly 12 times the 5 years. So on your notes, guys, please write down all of these different variable components. Otherwise, if you're just typing in your calculator, your notes aren't really going to help you later when you're trying to figure out what you did. And then for the app, the interest rate is not going to be written as a tiny decimal. So 5.5 is what we're going to write for interest. The present value of your account is empty, so you got nothing. And you're not going to add any additional money. So you are going to, oh, I'm sorry, back up. Isn't that what we're looking for? I was about to do something really dumb. We're going to have no money ever. We're never going to get around the world. This is what we're trying to solve for. So what I do in my notes when this is the thing I'm trying to solve for, I put a box around it, and then I write like the word solve, which tells me when I get to that point on my calculator, I do that second, alpha enter thing. All right, payment. This is the thing that's nothing. We are not making any monthly payments besides the interest, but we're not contributing anything more. So the future value is I want to have $10,000. There we go. And then payments and compoundings per year should both be 12. So 12 times a year, you, this is kind of stupid. You make a payment of nothing 12 times a year, and you collect interest 12 times a year. All right, so to our calculator. Go to apps. Very first one is finance. TVM solver. And then for the n, you can just, I already forgot what it was. What was it, 5 times 12? You can just type 5 times 12. It'll automatically change it to a 60 once you get out of that menu, or that part of the menu. Interest was 5.5. I'm going to be calculating the present value. That's what the question is, so leave that alone for a minute. I'm not making any payments. I want to have 10,000. Apparently, because I just want to go to like Newfoundland and then stop. And then 12 and 12. So once you get those entered, go back to the present value option, and you can either overtype or clear it out, whatever you want. It's going to overtype once we do this next step. I need to command it to calculate. Who remembers what I typed to command it to calculate this? So alpha enter, yep. Alpha enter, there you go, boom. You need to invest $7,650.50 right now. Find it. Also, you should try to find an account that pays 5.5% interest. That's curious. So that's what it looks like when you use the app, even though you didn't really need to use the app. So we didn't have any monthly payments going in, so we just put a 0 in for that. So this was a case where I could have done this in Algebra 2 using another method. And remember, guys, always have your payment set up at the end. That's the default for your calculators. Don't ever mess with that. It has to do with when they make this problem, it wouldn't have mattered. But if you invest like $50 every month, if you pay it at the beginning of the end of the month versus the end of the month, that changes your final outcome because you're going to have an additional payment that the other person next to you doesn't have. So you'll notice if you switch that, you'll have a slightly different answer, and we don't want that. All right, number 5. You know what, this one's kind of boring. They just want you to investigate like the parenthesis part of that formula and decide who has a bigger decimal. Okay, it's a very curious problem. All right, look at number 6. You have your first full-time job. So straight out of college, and you're going to start preparing for your retirement because you're a responsible 22-year-old. You are planning on working for 40 more years, and then you want to retire. That's cute. And then you're going to invest $50 whole every month into your retirement. Good for you. All right, so 6.5% interest compounded monthly. Let's use our app. So we're compounding monthly for 40 years. Sounds nice, doesn't it? All right, interest rate, 6.5%. Presently, I have nothing. But this time I am paying every month $50. The future value is what we're trying to find, right? So that's going to be my solve thing. And then you're compounding and paying every month, so 12, 12. Alright, we're going to get this data entered, and you're going to find out how much you have in your retirement account after 40 years of hard work and investment into your bank account. And we're all going to learn a very difficult lesson in a minute. What was this one again? 6.5. You got nothing in the account. You're paying 50 bucks, 12 and 12. And the thing we need to calculate is the future value. So once you get your cursor into the future value, command it to calculate. So alpha, enter, will solve it. And you have $114,000, $180.95. Write that down. And then let's have a little moment. Is that enough money to retire on? I mean, you guys probably aren't even thinking about this. The answer is no. Anyone know how much money you need to retire? Let me put it this way. Your parents need $1 million to retire. So you, who have yet to start your careers, will logically need more. You're going to need to invest more money than 50 bucks a month. Or maybe get some more aggressive options. Because, like, let's be honest, guys. You're not going to find a bank account that has 6.5% interest. You might be able to find some mutual funds that are aggressive and collect a lot of interest in theory. But all right, so the point here is, yeah, that's not a good option. Let's try something else. The next problem says, we're going to redo that question, but somehow we found an even better bank account. We found one that gives us 7%, and I'm willing to invest $100 a month. Let's see if that makes it better. And, oh, even better, I'm willing to work 45 years. This is adorable. 45 years. All right, so 12 times 45. I think I'm going to be here forever. I don't think I'm ever going to retire. Not by choice, by the way. All right, interest rate is now 7%. I have no money right now. We're going to make $100 every month, or invest $100 every month. Compounding and collecting interest. Paying and collecting interest 12 times a year. Let's solve this baby. So slightly better interest rate, working a few extra years, and investing double the amount of money will get you more than triple the return. Now, it's still not enough to retire, but it's better. So $379,259.47. Make sure you count that 47 cents. Every penny. I have a solution for you. You just don't retire. My plan. Or don't have children. And then you'll have lots of money. Or, if you have children, don't give them any money. Ever. You're on your own. College, good luck, child. Alright. Birthdays, I have them too. Alright. Number 8. Okay, this one would have been a good problem for, like, my dad. Not so much for me, but let's say I need $1 million to retire. Let's say. Okay. You're willing to work. That's good. And make investments for 50 years. Oh, all right. You're able to earn 8% interest somehow. Cool. What would your monthly contribution have to be? So this is important. Number of collections here. All right, so monthly for 50 years. Your interest rate is 8%. I have no dollars right now. I'm going to figure out what my monthly payments have to be. So this is the thing that we're going to have to solve. And then I want my future value to be $1 million. And we're making monthly payments and also compounding interest every month. All right, give me the bad news. What do I have to invest every month? It's actually not as bad. I think it's 126.08 cents. Yeah? That's not too bad. You can do that. That's like going to Starbucks a few times a week, right? You got that. All right, let's take a look. This is probably more up your alley, guys. Car loans. I really doubt you guys are worried about your retirement at the moment, although maybe now you are. And you're probably not worried about buying a house anytime soon, but probably in the nearer future, you're worried about buying a car. So after this worksheet, you're all going to think, oh man, I'm going to have to bring my TI-84 to my car loan application. And yeah, you should. You really should. All right, you want to borrow $7,000 to purchase a car and pay off the loan over a 5-year period. It's very standard for a car, 5-year. What's the monthly payment going to be if your bank account that's loaning you is going to charge you 6.8% interest? Now, I will tell you, that's a really high interest rate, but car loans are usually higher than like home loans, so keep that in mind. All right, sometimes you get 0. That's nice. N is 5 years of monthly payments. Interest rate 6.8. The present value is what they're referring to is the amount of the loan that you took from the bank. So how much money did you take from the bank? $7,000. And I'm going to try to calculate the payment, so that's the thing I'm going to solve. The future value, after you pay off the loan, what should the loan be? Yeah, it better be 0. And then you got 12 payments and 12 compoundings. So do a little calculation for me. And this is a money answer, so round to the nearest cent. I think I got $137.95, if I can get a confirmation on that. Awesome. Now, it's a really small car payment, but that's because that was a really small amount of money to take out for a loan. $7,000 used car. It's probably doable on your college income of nothing. Oh wait, no it's not. Let's look at, I love this question. Suppose you can afford a $250 monthly payment, but only for the next 3 years. Because like, what's going to happen to you after 3 years that you can no longer afford this car payment? I don't know, but something. I don't know what your life plan is, but in 3 years, you're like, I gotta get this car paid off. So here we are. We have an interest rate of 5%. How big of a loan can I take out? And these are, you know, you guys probably haven't gone car shopping too much, but when they like pre-qualify you for things, they ask you questions like, okay, they look up your credit score, of course, or your parents' credit score, and they say, what do you want your monthly payments to be? And then sometimes you don't give them a good enough answer, so then they're like, well, how much do you want your car to be? And they don't like that answer either. And then they bamboozle you with numbers. Watch out. They do this. All right, so let's recalculate this, guys. We are doing, what are we doing here? 3 years of monthly payments. Interest rate, 5%. Present value, that's the question, right? I don't know what it's going to be, so this is what we're going to solve. For some reason, I have this number 250 stuck in my head. I can afford a $250 payment. We're going to be paying it down to nothing every month. Every month. And this is a good calculation. I mean, I scoff at this problem because I kind of laugh at the I can only pay it for 3 years thing. My dad does this a lot. He doesn't like long-term loans on cars, so he'll shorten the term of the loan by making higher payments. But turns out that interest rates on car loans aren't usually high enough to make that. Anyways, I digress. So you guys should, if you're going to buy a car, this should be part of your calculations. Like, okay, feasibly, like what can I afford every month? And that should kind of be the basis for what you're going to take out. Don't have a number in your head of like, I need a $10,000 car, because a lot of things affect that number. Interest rate, how long your loan is. All right, so what'd you come out with? $8,341, and thank goodness for that 43 cents at the end. So then you walk in and you're like, I can afford an $8,341.43 car. And then they're like, here you go. No, don't do that. All right. Put that aside, except now, good news, you have 2 more assignments you can finish for me. Now, your homework check's a little confusing, a little misleading. The very last thing on the homework check where it talks about review, and it's like worksheet 7, worksheet 7.5, and then a review sheet. While I do encourage you to review for your test on Friday, we're not going to attach any of those into your homework check. So make whatever notation you want. You're not going to attach anything on that last row of the homework check. So that means the final 2 assignments that are in your homework check are what you're going to do for me tonight, which are the worksheet 5AB thing, which is pretty much the whole worksheet. I'm going to be honest. I think I just crossed off number 2 and 4 and everything else you have to do. And then the page 171, numbers 1, 3, 5, 7, 9, 13. So all of these problems, they're all finance. Yes? Oh. Oh, at the front of the packet? Yeah. Okay. Like the problems are different? Like, no, they're just worksheet 5A. It's smushed with the page 171, I bet. They're probably all together. Is it on there then? I do have an extra homework check thing if you want it though. Yeah, it'll say like worksheet 5A, 1, 3, 5, 6, 7, 8, 9 or something. Yeah, that's... These two are the last assignment. Yep, yep. So this is tonight's homework officially. I want to talk a little bit about on worksheet 5. It is on your pink formula sheet, but I think it's a little difficult to understand. You guys really need to use what's referred to as the half-life formula and sometimes the doubling formula, which in chemistry you guys either have or will use quite a bit. But on your pink formula card, I forgot what, I think they use N. I think it looks something like this. So like N equals N sub naught, and then there's like some mysterious rate, and then they use T and H, I believe. You might want to jot that formula down on worksheet 5 just because you're going to need it a few places. In chemistry, these questions make lots of sense because you're talking about like an isotope usually, and you're looking for like a half-life of a certain isotope. And for my friends in chemistry, they would tell you that that means a half-life, which they call H, is the amount of time it takes for your sample to be cut in half. So for like a radioactive isotope, they have measurements out there where they're like, okay, carbon, I don't even know an isotope anymore. It's been too many years. Carbon, whatever, has a half-life of, 137 million years, and that'll go into the formula. T represents how much time has gone by, usually. And then R is it's like what's usually in the parentheses, so it's 1 plus a rate or 1 minus a rate. So if you think about like half-life, if you take 1 minus 0.5, you're left with 0.5 or 1/2. So when they call it the half-life formula, you're going to see like a half put into the R here. That's what they mean by that. The problem that I'm referring to is number 5. Has absolutely nothing to do with like a chemistry problem for half-life, but it has everything to do with that formula. So its atmospheric pressure is 14.7 pounds per square inch at sea level. And then it says it's reduced by half for every 3.6 miles that you go up in altitude. And that rule applies all the way up until 50 miles in altitude. So just think of this like logically. You guys probably don't really dig up too many dinosaur bones to talk about half-life, but I think we've all had that experience where when you go high up in altitude, the air just feels different, right? Everything just feels weird. So your atmospheric pressure is decreasing depending on how high up you're going, which changes a lot of things. So the formula here, it's kind of confusing because we use like T for time, but we're not measuring time on this question, we're measuring altitude. So your initial amount is what goes in front. So I think they said that was 14.7. And then it says it's halving every time you go up 3.6 miles. So 1 minus a half is still going to be a half right here. And then T is kind of confusing because we always say T is time. Well, in this problem, T represents how many miles you've gone up. So for this formula, leave it as X or whatever variable you want. And then for the half-life, that's the increments in which it halves. So like every 3.6 miles you go up, the pressure is going to half itself. So this is 3.6. So that's kind of the basis of the formula you're going to have to use for number 5. Everyone always asks about number 5 because it looks like a half-life question, but it's not a normal half-life question like a chemistry one. Just have that pink formula sheet handy when you're doing that worksheet. Okay? Could you, and this is going to seem really random, could you please find worksheet 9? So remember, next week you have only Monday and Tuesday, and then you get a ridiculously long Thanksgiving weekend. Trust me, I'm looking forward to it just as much as you are. So in order for us to kind of get to a comfortable place in our curriculum so we're not like hurting at the end of the semester, I need to really quick review with you how to solve some exponential and logarithmic equations. So I really like worksheet 9. It shows you, like, if your problem looks like this, do this. If your problem looks like this, do that. So yeah, this is a review from Algebra 2. Like everything in math, there's more than one way to teach these concepts. What I'm going to do here for you in PreCalc is I'm going to teach you like the algebraic roots of it, rather than like just magically use a formula and then here you go. So if it's different from what your Algebra 2 teacher did and you would like to revert back to what your Algebra 2 teacher did, I'm okay with that. They all mean the same thing. The process ends up being the same. I just really like at your guys' level and age. Like, you understand where formulas are coming from at some point, and I would just rather you guys start using the formulas like they're supposed to be used. I always hate that when like little, like you guys aren't little anymore. You don't need to, I don't know, I digress. All right, so number 1 here, we have 2 questions, and it says if you have your exponent as a base, but it happens to be raised to a power, the way you approach this question is you isolate the base, and then you apply the reciprocal power is the easiest way to solve this. So like here, I would start by dividing both sides by 15. So you have x to the 2/3 power equals 4. And then the easiest way to get rid of a power is to apply the reciprocal. So the reciprocal of a 2/3 would be a 3/2. So as long as you can carefully type this on your calculator, 4 to the 3/2 power, which technically we could do without a calculator, guys. Do you remember what 3/2 power means? It means the square root of 4 raised to the 3rd power. So what's the square root of 4? 2 raised to the 3rd power. 8. The answer is 8. Alright, so on letter B, same idea. Isolate the base first, divide by 3, and you get some gross fraction decimal thing, so I'm just going to leave it as 57/3. Oh wait, is that nice? Oh, 19. Haha, ignore me. Alright, x to the 1.2 power equals 19. Now, kids freak out here because they're like, ooh, what do I do with a 1.2? How do you take the reciprocal of anything? You just flip the fraction. So if you called 1.2 1.2 over 1 and then you flipped it, wouldn't that be 1 over 1.2? Like, there's other ways to get a reciprocal of that, but your calculator is going to do the math, and it doesn't care what version of that reciprocal you give it. So what is 19 to the 1 over 1.2 power? Something gross, no doubt. 11.63-ish? Okay, very good. So those questions really don't belong in this lesson. These are the questions that we need to remember how to solve. So these are exponential equations. The variable is trapped up in the exponent. So this is where maybe your Algebra 2 teacher and your PreCalc teacher are going to differ a little bit in approach. Your variable is trapped. How do you get it down? What brings exponents down? A log. Yeah. So we need to isolate the exponential part. Let's divide by 50. So you have 3 to the 2x power equals, is that 25? Okay. So in order to drag or bring the exponent down, I'm going to have to apply a logarithm. Now, some of your Algebra 2 teachers taught you to apply a logarithm of the base of whatever the base of the exponential was, and then later on you use change of base formula to get the answer. We're actually going to have the exact same math in a minute, but what I want you guys to understand is what you're really truly doing. You're supposed to be applying a logarithm with the intention of using a calculator in a minute, right? We're going to have to use a calculator on this question, or we're going to have to use a chart, old school. We're not using charts. So since I'm going to use a calculator, why not use the quick logarithm keys, which are the 2 that are on your front keypad, common log and natural log. Okay, what's a common log base? 10. What's a natural log base? E. We don't have either of those bases here. So it's your choice whether you use a common log or a natural log. So literally it doesn't matter, except if your name is Mrs. Abruzzo. It totally matters, and I'll tell you why. This is just a testament to my laziness. Natural log has 2 letters. Log has 3. Natural log it is. Because it's also really pretty when you write it in cursive. I don't know. Guys, back in college I was like, oh man, I gotta write a lot of logarithms in this class, differential equations. And I was like, ugh, I'm sick of writing logarithms out, so I started writing natural logs only for this very reason. And then they ended up looking like this, because, like, I can't write. So, whatever. Anywho, if you ask me, I choose natural logs. Unless it's base 10. Hi, thank you. Elijah. Oh, you're good, though. I need to get this to Elijah. He's got to leave. No, you're fine. I also have passes for a bunch of people up here, so don't leave until I get these passed out. All right, here we go, guys. So why do we apply the natural logarithm? Because it's going to take your exponent and it's going to use the power property where it brings the exponent down in front. And now it's 2x times the natural log of 3 equals the natural log of 25. Notice I haven't touched a calculator yet because none of this is going to come out pretty, guys. We're going to have to understand that natural log of 25 is gross. Natural log of 3 is gross. So I'm going to think about algebra. I would divide this gross number over. And actually, what else are you going to have to divide by? You're going to have to divide by 2 as well. So whether it's in 1 step or 2 steps, I don't care. I need you to take natural log of 25, close the logarithm. I need you to divide it by the natural log of 3, and then you also have to divide that answer by 2. So people who use change of base, look what this is, guys. That's literally the same thing as change of base. That's where change of base comes from, okay? What you got here, by the way? Something gross. 1.46-ish? Okay. Let's just go hundredths place on this. That sounds good. All right, so same idea here, guys. We're going to divide both sides by 6.6. And I really encourage you guys to do as little typing in the front of the problem as possible. Like pretend you don't have a calculator, just to get ready for the moment where you literally won't have a calculator. Because if you can manipulate this without the calculator, you'll be in better shape later. So I need to apply a logarithm. This is not a base 10 or a base e, so it's your choice technically, except we all know I'm going to choose natural log, but whatever. Do what you want. What you want. What'd I do? 0.5. That would have been terrible later. Good call. Good catch. Okay, anyways, common log, natural log. You really don't care, do you? You're like, just do what you want, Abruzzo. You're going to anyways. All right, natural log. Natural log of 0.5. Nothing great, but the x does come down in front. So it's x times the natural log of 0.5 equals the natural log of whatever this gross mess is. So you're going to divide by the natural log of 0.5. Please do practice typing this one in, guys. Kids sometimes just aren't familiar with how to type in a log and when to use parentheses and when not to use parentheses. So you need to type the natural log of 0.8 divided by 6.6, close the logarithm, divided by natural log of 0.5. If you chose a different type of logarithm, just make sure you're using the right type of logarithm for both the parts of the ratio. And you should get 3.04-ish. Oh, good deal. All right, now on this next one, we're gonna, is it something other than, is it because of truncation? Yeah, if you truncate this decimal up here, guys, the rest of your work is going to be a little off, so be careful. Divide by 150. Now this time, it'd be very smart for everybody to use natural logarithm. Tell me why. The natural log is a base e logarithm, which means when you apply natural log to the base e exponential, not only does the exponent come down, the e and the natural log knock each other out. So you end up with 0.5x equals whatever the natural log of 600 is. And then you're going to divide both sides by 0.5. Now, I've seen on standardized testing this question on a no calculator portion of the test. And they'll leave their answer just like this. They'll say, which of the following is equivalent to the solution to this question? And they'll leave it as like log 600 divided by, or natural log of 600 divided by 0.5, or some other equivalent way of saying that. So they're really, truly testing, like, can you figure this out algebraically? Because if you can't, you're going to have a heck of a time getting that answer. Anyways, it comes out to 12.79-ish. All right, cool. So those are all exponential equations. So in order to bring an exponent down, you applied a logarithm. So how do you get rid of a logarithm? Does anybody know the word? Exponentiate. That a girl. So this really, and this is where, whoa. I don't know what happened to my letter. Okay. It's doing it again where it just drags random things around. I don't know what's happening. Okay. I don't know what's going on. Okay. Exponentiate. Depending on your Algebra 2 teacher, you may or may not have been taught this method. Some Algebra 2 teachers say, just use the rewriting method where like you put the base to the answer equals the number. And that works because of what we're talking about, which is exponentiation. So you guys are old enough to understand, like, formulas are great, but let's talk about what's really happening here. What base is that logarithm? I know it's a common log, but what base is it? It's a base 10. Very good. So, there we go. It's a little 10 here. So you can do whatever you want to an equation as long as you do it to both sides. So technically, and you've probably never thought of this until algebra, if you wanted to take a base and shove it underneath the problem and hoist the problem up into the exponent position, you can do it as long as you do it to both sides. So watch what we're going to do here, guys. We're going to take the same base as the logarithm, which is a 10, and we're going to shove it underneath the problem on both sides of the equation. So here's what you have, guys. You have 10 raised to the log, oh gosh, my cursor's gone, and now I don't know where I'm writing. Hold on. Arg. We'll probably get to the end of the lesson, and now it doesn't work. Okay, 10 to the log 2x plus 20 power, there we go, equals 10. Okay. Video's over. Figure it out yourselves, children. Look at the slides.